Okay, you don't always just have to have two masses for conservation of momentum. I'm going to show you a situation where you can have three or more masses, and in fact, in this case, you're going to have four masses. You're going to have the math teacher, the chemistry teacher, and the physics teacher, and you can tell the physics teacher because he's got big muscles. And you can tell the math and chemistry teacher, this toque with a big pom-pom, and this toque's got little ear flaps, and this is just a regular old toque. Now what we're having here is a situation where going on a sleigh ride. So we're all meeting at the sleigh beforehand, and we get on top of the sleigh. The cart itself weighs 120 kilograms. Now what's going to end up happening is you're going to have the math person is going to get shoved off to the left by me. Then you're going to have the chemistry person is going to jump off to the right, being scared that they're going to get pushed off by me next, and then me, after spending all my time always going after the chemistry teacher, I'm going to chase the math teacher off. So instantaneously what's going to happen is the math teacher is going to go left, I'm going to go left, chemistry teacher is going to run away scared to the right. Initially, the cart with all the people on it is not moving. So our initial momentum is 0. Then we're going to have the math teacher's mass with their velocity plus physics teacher with my velocity, and chemistry teacher's mass with the chemistry teacher's velocity. And what we want to find is we want to find the mass of the sleigh. We want to know this velocity of the sleigh after math goes left, chemistry goes right, physics goes left. What does this sleigh do? Does it go left, right, or does it possibly stay in one spot? So let's fill everything in and find out. Math mass is 100. I'm telling you that it's jumping left. I'll tell you that it goes left at 3.8. Physics, 105. Tell you it goes left. Goes left at minus 4.3. Chemistry teacher weighs 85. They go right at positive 8.3. And the cart, or the sleigh, is 120. And we want to know the velocity of that sleigh after. Okay, so that's what we're doing. We're going to figure this all out. So solve it out. Velocity of the sleigh ends up equaling minus 380 minus 451.5 plus 705.5, all divided by 120. Plug it into your calculator. You end up getting a value of minus 1.05 meters per second. That means that the sleigh goes left at this velocity. Okay? If you wanted to make this question a little bit more difficult, now you could say, okay, well, after these three people jump off in different directions, we know that the sleigh is going to move this way. If we wanted to stop the sleigh from moving, you could have another object. So maybe you have the English teacher standing here, and you'd say, well, no, they have to move off to the right. At what velocity to the right do they have to go with their mass to stop the sleigh? And you just make sure that the momentums cancel out. Okay, so it can be done. But there you go. Conservation momentum with three masses or more. 1, 2, 3 plus this one makes the more. There you go.